is a third example of solving rational inequalities for my Math 161. Ooh, we have this on the right side. I'm going to move this to the other side so that we can have 0 on the right side of the inequality. So that was the goal for every problem that we've been doing. So that's how we get started first. So look, for the first example, when we had a 2, we subtracted 2, okay, to get this 2 canceled out. When we had x, I subtracted x from both sides so that we have 0 on the right side. So same thing, we're going to subtract whatever, or I may sometimes have to add if it's a positive. We're going to have to move this fraction 2 over 2 minus x to the left side so that we can have nothing on the right side. So it was negative 3 over x minus 5. That was the original fraction. That was the only one on the left, right? But if I subtract minus 2 over 2 minus x, that's a new guy from the right side of the inequality. Then now I will have less than or equal to 0. Now, unfortunately, you cannot just pick the zeros of the numerator and zeros of the denominator yet. Of course, you will plot x equals 5 and x equals 2. And if you're like, where'd you get those from? If you plug in 5 in here, 5 minus 5 will make the first fraction 0. If you plug in 2 in there, 2 minus 2 will give you... But that's not going to be enough, guys. You will have to find a single... You're going to have to first rewrite this so that we have a single rational expression. So let's start talking about the common denominator, okay? Oh, goodness. Right, let's see. The common denominator, to make those common denominators, I need to multiply the first fraction by the denominator of the second fraction. So look, it used to be negative 3 over x minus 5, right? Now, on top and bottom of that fraction, let me multiply 2 minus x over 2 minus x. You know exactly where I got 2 minus x from. That's where I got it, okay? Now, I'm done with the first fraction. Go on to the second. I will draw the original fraction of 2 over 2 minus x. But this fraction will now get multiplied by x minus 5 over x minus 5. And if you're wondering, where did you get x minus 5 from? Oh, I got it right here. That was the denominator for the first fraction. So now they have a common denominator. So I'll go ahead and say these are all less than or equal to 0. So because they have a common denominator, I'm now going to put them together in a single fraction. So I will say that great circle part is my numerator. So I'll go ahead and write that in a single line. Negative 3, 2 minus x, close parenthesis, minus 2, x minus 5. That's my numerator. And all over, I can just write down, and the order doesn't matter. I'll write down x minus first, x minus 5 first, and then I'll write down 2 minus x. The order doesn't matter because it's just multiplication. Okay, now we need to simplify the numerator. Can you distribute very carefully with signs? Okay, so I'm going to distribute negative 3, and I'm going to distribute negative 2. When you are done distributing, we should be able to identify some like terms. So I'll get negative 6 plus 3x minus 2x and plus 10. All that is over x minus 5 times 2 minus x. And don't forget, we're trying to solve this inequality, so keep on bringing this less than or equal to 0 down until we are ready to solve these, okay? Now let's look for some like terms. I see there is 3x, they're right next to each other. 3x minus 2x. So these two will combine and give us 1x. And negative 6 and positive 10, those will combine and give us plus 4. So we're done simplifying the numerator. Numerator is simply x plus 4. The denominator is x minus 5, 2 minus x. So now we're ready to find the zeros of the numerator and the zeros of the denominator. So, I wonder if I can, I'll move the work to the side again, okay? Or maybe I'll just work it down here. Okay, so what is the zero of the numerator? Zero of numerator is when x plus 4 is equal to 0. So x equals negative 4 is going to be one of the boundary points. And what kind of circle would you put? Because for the zero of the numerator, it can be a closed circle, and that depends on the symbol. And because the inequality symbol said less than or equal to, I will plot a closed circle here. So many things to think about, but you just have to, because when you get to the plotting point, you're going to have to think about, is it going to be a closed or open? And the zero of the numerator depends on the symbol. But zero of the denominator, zero of denominator is always going to be always open circle. Why? Because we can't have a 0 in the bottom of the fraction. This is just going to be vertical asymptotes, okay? So, what are they? X equals, if you look, x minus 5 is a factor. That means x equals positive 5 is a 0. And what's the other one? If 2 minus x is a factor, then 0 must be positive 2. Because 2 minus 2 is 0. So I have all the zeros identified, but these two will be open circle. Okay, these two will be open circle. Let me go ahead and draw a number line here, okay? I'll draw I'm going to need a lot of room over here. I'll draw a number line with negative 4 on the left, who has an open circle, closed circle, 2 in the middle, open circle, and 5 right here, another open circle. Okay, so what I want to see is which intervals will give us a statement that satisfies this inequality. So it's time for us to plug in some values, okay? Let's pick a number that is to the left of negative 4. Okay, how about I plug in x equals negative 5. If I plug in negative 5 into that circled, the orange circled inequality, I will get negative 5 plus 4 over 5, not 5, negative 5 minus 5 times 2 minus negative 5. Oh, we have to be careful with all these symbols. And I want to see if that is less than or equal to 0. So excuse me. Let me add another page after this so that I don't use the room for the next page, okay? Next problem. I will go ahead and add a page right here. That's good. And I can just work my way down. So if I simplify this, the numerator will be negative 1, right? And the bottom of the fraction is negative 10 times. This turns into 2 plus 7, isn't it? So a 2 plus 5, isn't it? Okay, sorry. But which is 7. Let's check this. That is negative 1 divided by negative 70. Is that true? Well, negative over negative is positive. So 1 over 70, who is a positive number, is not less than or equal to 0. So this is a false statement. Because this is false, this far left interval, that is to the left of negative 4, is not going to be the answer region. So I'm not going to highlight that section. All right, next interval. Let me go ahead and pick a number that is in between negative 2 and positive, negative 4 and positive 2. Let's plug in x equals 0. Because 0 is in between negative 4 and 2, isn't it? So if I plug in 0 into this inequality, stop. Wouldn't I get 0 plus 4 over, let me see, what was the function? 0 minus 5 times 2 minus 0, right? 2 minus 0. 2 minus 0. And I want to see if this comes out to be less than or equal to 0. Let's see if that's true. This is 4 over, stop it, negative 5 times 2, which is it less than or equal to 0? I don't know, we're about to see. 4 over negative 10. Oh, that's a negative number. And any negative number is smaller than 0, so this is a true statement. This is a true inequality. So I will go up here and I will mark this interval. I will connect them because anything in between those two numbers can be an answer. Okay? Doing good. We now need to check 2 more intervals. So let's do that. How about I just say I will pick x equals 3 here and then I'll do the work down here. Okay? So if I plug in x equals 3. Can I go ahead and copy the function here because I don't like going up and down. Let me go ahead and copy this down there somewhere so that I don't have to keep coming up. So here we go. I'm going to go ahead and plug in 3 in here, okay? So that is 3 plus 4 over 3 minus 5 times 2 minus 3. Everywhere I see x, I plugged in 3. I want to see if I simplify this, it will come out to be smaller than or equal to 0. Let's see that. The numerator is 7. The bottom of the fraction is negative 2 times negative 1, isn't it? Let's simplify this. This turns out to be positive 7 over positive 2. Is this true or false? Well, positive number is not smaller than 0. So we just got another false statement. This is false. So what does that tell us? The interval that we grabbed this x equals 3 from, okay, which is in between 2 and 5, that is not an answer interval, okay? So we skip that one. What is the next interval? The next interval starts from 5 all the way to positive infinity. So you can pick any number that is bigger than 5. I will go with 6. I will now go down to that page and plug in x equals 6, okay? So maybe this guy can follow me. All right, you follow me this time. All right. I just write so big, don't you think? Plug in x equals, I forgot what the number was. 6, it was 6. Let me go ahead and plug in x equals 6. X equals 6. If I plug in 6, I will get 6 plus 4. Oh my gosh. All right, hold on 1 second. 4 over 6 minus 5 times 2 minus 6. And I want to know if this is less than or equal to 0. Well, the numerator is 10. The denominator is 1 times negative 4. Is that smaller than 0? Well, let's see. The numerator is still 10, but denominator will come out to be negative 4. So is negative number smaller than or equal to 0? It is smaller than 0. So this is a true statement. So the interval that we just grabbed, x equals 6 from, is the answer interval. So let me go up here and I will underline or add that black highlight that starts from 5 and is going all the way to positive infinity. So we did it. We're going to have to just write the solution in interval notation. And I am so out of room everywhere, I will go ahead and write the solution here. Here's the solution. The interval that starts from negative 4 to positive 2. But I want you to pay attention how I'm using a square bracket in front of negative 4 because we have a closed circle. But I'm using an open circle at 2 because 2 was a 0 of the denominator. It can never be equal to 0. The bottom of the fraction can never be equal to 0. Okay? And then I skip the one in the middle. The next one starts at 5 with an open circle. So I'll draw a parenthesis, a 5, and it's keep on going to the right. So positive infinity will be it. So this one was a long problem. But take your time. It's a great practice for you to review your rational expression skills because you have to know how to subtract or add fractions by first coming up with common denominators, a lot of well, not really a lot, distributing, simplifying like terms, coming to the zeros of the numerator and denominator. It's definitely not a single step problem, but this is something that you can definitely do. So just take your time. As you can see, I spent about 15 minutes on the single problem, right? Alrighty, I will come back with the very last example of topic number 3 shortly.